Welcome to Saving Models. This lesson is part of Module 04, First Fine-Tuning Project. Let's get started. Let's now look at Lesson 4.6, Saving and Sharing Your Fine-Tuned Model. Here we can see the export format comparison. Let's now look at Overview. Here we can see the GUF quantization levels. You've trained and evaluated your model. Now it's time to save and share it. Learn to save low-rank adaptation adapters, merge them with the base model, choose quantization options, and optionally upload to Hugging Face Hub. Duration, 20-30 minutes. Difficulty, beginner to intermediate. Let's now look at learning objectives. Here we can see the deployment paths. By the end of this lesson, you will save low-rank adaptation adapters, lightweight, 50, 200 milliBRs, merge adapters with base model, full model. Choose quantization formats, 4-bit, 8-bit, 16-bit, full. Upload models to Hugging Face Hub, load saved models for inference, create model cards and documentation, understand file sizes and use cases. Let's now look at Saving Options Overview. Here we can see the model compression chart. Let's now look at three main formats. Here we can see the LoRa adapter structure. Format, size, speed, use case. Tesh. Low rank adaptation adapters only. 50, 200 MB. Fast load. Most common. Merged 4-bit, 2-3 GB. Very fast. Deployment. Merged 16-bit, 6-7 GB. Slower load. Training continuation. Merged full 32-bit. Titanium 12 to 14 GB. Slowest. Maximum quality. Recommendation. Save low rank adaptation adapters. Fast, small, easy to share. Let's now look at Option 1, Save LoRa Adapters, recommended. Here we can see the merge process diagram. Let's now look at Why LoRa Adapters. Here we can see the HF Hub upload flow. Pros, small file size, just 50, 200 MB versus 6 GB plus for full model. Fast to upload, download. Easy to version and experiment. Can be applied to any compatible base model. Cons, requires base model to use, two-step loading. Let's now look at Save LoRa Adapters. Here we can see the model loading from Hub. After training, model is in memory. Save only the LoRa adapter weights. Here's the bash code for this section. Starting with Models, my first LoRa. Let's now look at Check File Sizes. Here we can see the FileOrg best practices. Here's the Python code for this section, starting with import OS. Here's the bash code for this section, starting with adapter model.safetensors, 83.5 MB. Let's now look at load LoRa adapters. Here we can see the version management. Load base model plus your LoRa adapters. Switch to inference. What happens? 1. Unsloth loads base model, Llama 3.23b instruct from cache. 2. Applies your low-rank adaptation adapters on top 3. Ready for inference. Let's now look at Option 2, Merge LoRa with base model. Let's now look at Why merge. Pros, single model file, no two-step loading, slightly faster inference, can be used with any framework, no low-rank adaptation dependency. Cons, larger file size, GB instead of MB, slower to upload, download. Let's now look at Merge and Save, 16-bit full precision. Merge LoRa weights into base model. Let's now look at Merge and Save, 4-bit quantized. Merge and quantize to 4-bit. File size, 2-3 GB, smaller, minimal quality loss. Let's now look at Merge and Save, GGUF for Llama CPP. If you want to use the model with Llama CPP or Ollama, save as GGUF format for Llama CPP. Use cases. Local inference with Llama CPP, Ollama, LM Studio. Let's now look at Comparison Table. Save method, size, quality, use case. LoRa adapters, 85 MB. Full. Development, sharing, merged, 4-bit. 2-3 GB. Very good. Deployment, merged, 16-bit. 6-7 GB. Full, max quality. Merged 32-bit, 12-14 GB. Full. Further training, JGUF Q4KM 2-3 GD, very good. llama.cp. Let's now look at option 3, upload to Hugging Face Hub. Let's now look at why upload to HF Hub. Benefits, share with others. Version control, easy loading from anywhere. Free hosting, community visibility. Let's now look at prerequisites. Install Hugging Face, CLI login, one-time setup. You'll need 1. Hugging Face account, free, https huggingface.co join 2. Access token, create at https huggingface.co settings tokens. Select write permission. Let's now look at upload LoRa adapters. Upload LoRa adapters to HF Hub. Let's now look at upload merge model. First, merge the model, then upload. Let's now look at create model card. Create README MD in your model directory. My first fine-tuned model. Details intended use. Extract information. John Smith is 45 years old and works at Google. Here's the bash code for this section, starting with output. Name, John Smith. Age, 40 psych, company, Google. Usage. From unsloth import fast language model, tokenizer, so fast language model, from pre-trained model name, your username, my first LoRa, max sec length 2048, dtype none, load in 4-bit true, fast language model.4 inference model messages, darum, role, user, content, extract information, inputs, are tokenizer, apply, are chat template, messages, return, tensors, pt, to, CUDA, outputs, aren't, model.generate, input, IDs, inputs, max new tokens, 256, print, tokenizer.decode, outputs, are. Training details, limitations, citation. Amisk my first LoRa, author, Shakman your name, title, Sakwan, my first fine-tuned model, year, Shak 2024, publisher, Shakwan Hugging Face, URL, Sat to https, sheltonhuggingface.co, your username, Shakwan my first LoRa. License. Save this as models, my first LoRa, readme.emt. Let's now look at loading your saved model. Let's now look at load from local directory. Load LoRa adapters. Let's now look at load from Hugging Face Hub. Load from HF Hub, automatically downloads and caches. First time, downloads model, .85 MB, fast. Subsequent times, loads from cache, instant. Let's now look at file organization best practices. Let's now look at recommended structure. Here's the bash code for this section, starting with F, projects, fine-tuning. Let's now look at backup important files. Backup your best model, or create a zip archive. Let's now look at version management. Let's now look at naming convention. Here's the bash code for this section, starting with models. Include in model name, project name, version number, format, LoRa, 4-bit, GGUF, etc. Let's now look at deployment considerations. Let's now look at, for local inference, your machine, best choice, low-rank adaptation adapters, small file size, easy to load, can switch between different LoRa's. Load for inference. Let's now look at, for API server, production. Best choice, merged 4-bit model, faster loading, no two-step, single file, still small enough, it's like 2-3 gigabytes. Load merged model for serving serve with fast AP Flask, etc. Let's now look at, for edge devices, Llama CPP, Ollama. Export to GGF. Run with Llama CP. Let's now look at complete saving notebook. Save as notebook 03 first training 5 save model.ipmb. Osad Koesin, She Darde She. Cell 1, load trained model. Nzai Shain Sei Shurwa. Shai Soro Dan Gyao's load from outputs or from memory if just trained. Joy Sikidezi to sign cell 2. Save LoRa adapters. Let's now look at saving checklist. Here's the bash code for this section, starting with saving checklist. Let's now look at key takeaways. 1. Low rank adaptation adapters, Jackson's best default, small, fast, shareable. 2. Merged 4-bit, best for deployment, fast loading. 3. GGUF, best for Llama, CPP, Ollama. 4. Upload to HF Hub, easy sharing and version control. 5. Model card, essential documentation. 6. Backup regularly, don't lose your work. Let's now look at Module 4 complete. You've successfully loaded a model with Unsloth, prepared and formatted data, configured training parameters, trained your first fine-tuned model, evaluated performance, saved and shared your model. Your model is ready to use. Let's now look at what's next. You have a working fine-tuned model. Now level up your skills. Continue to Module 5, Chat Model. Fine-tuning, learn advanced techniques, multi-turn conversations, personality customization, system prompt engineering, chat-specific optimizations. Let's now look at additional resources. Hugging Face Hub documentation, model sharing guide, GGUF format guide. Congratulations on completing Module 4. That wraps up saving models. Well done on completing this lesson. See you in the next one.